Quadratic equations. If you take a look at the graph here on the right, you notice that we have a parabola, which comes from a quadratic equation. And notice that where the parabola crosses the x-axis are the solutions to that quadratic equation. They call that the zeros of the function. So whenever the parabola crosses the x-axis or touches the x-axis is where there's a solution or a zero to the function. We could find those solutions, we could find those zeros algebraically by taking the quadratic equation and using the zero product property that we will do by factoring to find the zeros of the function. So for example, they show you the zero product property down here. And basically what they're saying is that if you have two factors, a times b equal to 0, one of those numbers, a or b, has to be a 0 for the product to be 0. We're going to use that with factoring to find the solutions or the zeros of a quadratic equation. So here we have one. They want the solutions, meaning the zeros, of the quadratic equation x squared minus 5x plus 6 equals 0. So remember that solutions are the same as zeros, same as roots. All right, so all of these names for solutions are interchangeable. So to solve this using the zero product property, we have to factor first. So to factor x squared minus 5x plus 6 equals 0, we notice that it's not a perfect square trinomial. There is no GCF other than 1, and the a value is equal to 1. So when a is equal to 1, we said that we set up two parentheses. We're looking for two factors that multiply to 6 and add to negative 5. So the two factors, the two numbers, would be negative 3 and negative 2. So we'll have x minus 3 and x minus 2. Notice if you multiply the negative 3 to the negative 2, you get a positive 6. If you add them together, you get the negative 5. Once you have the factors, what you do is set them equal to 0. And solve for x in each one. So here, if we add 3, we get x equals 3. Here, if we add 2, we get x equals 2. So the solutions to this quadratic equation are 2 and 3. Here again, they want the solutions of the quadratic equation, x squared minus 7x equals negative 12. Now, before you could work on factoring it, you want to make sure that it's in standard form. So the first thing we'd have to do to get into standard form is to add 12 to both sides. That will give us x squared minus 7x plus 12 equals 0. Again, no GCF other than 1. It's not a perfect square trinomial. A is equal to 1, so we know that in that case, set up two parentheses. X will go in the first position. And now we need two factors of 12 that add to negative 7. So that's going to be negative 4 and negative 3, because negative 4 times negative 3 gives us positive 12, and negative 4 minus 3, negative 7. We take each factor, set it equal to 0, and solve each one for x. Okay, so our solutions here are going to be 3 and 4. Okay, here they want the solutions to the quadratic equation. We have something similar to the previous one where we have to put it in standard form. So first thing we want to do is subtract 15 from both sides. So that'll give us 2x squared plus 7x minus 15 equals 0. Okay, so what we want to do is factor it because it's not a perfect square trinomial, no GCFs greater than 1. So this is going to be A is not equal to 1, where we have to multiply A and C together first. So if we do that, we get a negative 30. At this point, we need factors of negative 30 that add to 7. So we could do 10 and negative 3. When we multiply them, we get negative 30. When we add them, we get 7. We're going to use the 10 and the negative 3 to break up the middle term. So now that we have 4 terms, we're able to use grouping to solve this. So our GCF for the first group is going to be 2x. And the GCF for the second group will be 3. So our factors are 2x minus 3 and x plus 5. We're ready to take each factor, set it equal to 0. And we're ready to solve for each one. Okay, so we have solutions of negative 5 and 3/2. Now, something else that we can do if we're solving by graphing, using the graphing calculator, another way to get this done, depending on how the question wants you to solve the equation. If they want you to do it algebraically, you would do it by factoring. If they want you to use your calculator to solve it, you can get the answer through the graphing calculator. So we could take a look at this one and find the same answers on the calculator. What you want to do is get a graphing screen and then graph the expression that we had before. It was 2x squared plus 7x minus 15. Okay, we don't have to adjust the window because what we're interested in are the zeros. So in other words, where the parabola is crossing the x-axis. So as long as we can see that portion of the graph, we're good. So the first step is to hit menu, going to analyze the graph. We want the zeros this time. So we're going to work with this one on the left and get a lower boundary. We'll get an upper boundary right next to the point. So you can see that negative 5 is one of the solutions, which is what we got before. We'll do this again for the other 0 on the other side. So analyze graph, 0. So my lower boundary before the point, upper after the point. And you notice that 1.5, which is the same as 3/2, is the solution on the other side. So our solution, as we got it algebraically, is 3/2, which is 1.5 and negative 5. Okay, they want the solution to the quadratic equation. So here it's already in standard form. So again, no GCF other than 1. Not a perfect square trinomial. A equals 1, so it's 2 parentheses. X in the first position. And then we need 2 factors that multiply to negative 24 and add to 2. So we could do 6 and negative 4. 6 times negative 4, negative 24. 6 minus 4 is 2. Now we're able to take each factor, set it equal to 0, solve for each one. So negative 6 and 4 are the solutions here. Again, if we wanted to check that on the calculator, we can graph that equation. So that was x squared minus 2x I'm sorry, that was plus 2x. Hang on. And then minus 24. Okay, so again, we don't have to adjust the window. What we're interested in is just where we could see it. So it's again, menu, analyze graph, 0, lower bound before the point, upper bound after the point. So there's our negative 6. Then we'll do it again for the other solution. So menu, analyze graph, 0, lower upper bound, and 4 is the other solution. So we get the same answer that we did when we did it algebraically using the factoring techniques. All right, so here's a little application of a quadratic equation. They talk about the celebrated jumping frog of Calaveras County that Mark Twain wrote in 1865. And they tell us that frog jumping competitions have been growing in popularity. The graph shows a function modeling the height of a frog's jump. X is the distance, and Y is the height. So the first thing they're asking for is how far the frog jumped. So if X is the distance that the frog jumped, we want to see from the starting point how many feet it took until he landed at this part here, this part of the graph here. So best thing we could do is take the equation, and let's put it in our own calculators, and then we can do some analysis on it. Okay, so the equation they gave us was negative 0.29 x squared plus 0.59 x. All right, so that's the equation that models the jump. Need to fix that. It's 0.029. Hang on. So we need a 0 in there. Okay. Just have to adjust the window. So that's a window zoom. Do a zoom fit. And we'll have to zoom out a little bit. Okay. So now we have a graph that looks similar to the one that we saw in the picture. And let's see, the first question was, how far did the frog jump? So the x-axis is the distance. So what we want to find out is what this 0 is here at the point where the parabola touches the x-axis. So let's see what we have. We're going to go to Menu, Analyze Graph, 0. So we have a lower boundary, an upper boundary, and all right, so it says that the frog jumped 20.3 feet. So let's go back here and we'll just jot that down, 20.3 feet. It wants to know how high did the frog jump. So the height, the maximum height, is what we want to find on the parabola. So let's see, if we do Menu and Analyze Graph, we want the maximum. So we have a lower bound and an upper bound. So it's telling us here, remember that the y coordinate is the height here, so it jumped as high as 3 feet. Let's write that down. Now they want to know what's a reasonable domain and range. So if you recall, when we talked about domain and range for a parabola, we said that generally speaking, the domain is all real numbers, and for a parabola with a maximum like this, that the range would be y is less than or equal to k. Well, those generalities are not really a reasonable domain and range for this particular situation, because if you think about it, the frog can't jump an indefinite amount. He's got to come down at some point, and the frog also can't jump an infinite height. The frog is only going to be able to jump only so high. So based on what we're looking at, we want to get a reasonable domain and range. So what we could say is for the domain is that, well, we know that the domain is x. We could say that x is going to be greater than or equal to 0. It's going to go some distance. And this frog jumped 20.3 feet. So maybe we could say a reasonable jump might be 25 feet. We'll even give them the benefit of the doubt. We'll say, maybe there is a frog out there that could jump as far as 30 feet. So we'll say that's a pretty reasonable domain. For the range, we're looking at y. And again, we know he's going to jump some distance, so greater than or equal to 0. But it's not going to jump an infinite distance. So we could say that if this frog jumped about 3 feet, that a reasonable range might be, for a really good frog, 5 feet. So we could say that for the range, y is greater than or equal to 0 and less than or equal to 5. And that would give us a pretty good idea of what a frog can do in a competition.